Welcome back to the Foundry by Forge College. Today, we're jumping right into designing feedback loops for continuous improvement. Now, if you caught our last explainer on aligning tasks and monitoring for deployment, which, is a key piece of our Solana pre-deployment series, you've already got your system visibility locked in. We map those integration tasks to monitoring checks, which is awesome. But today's the day we actually upgrade you from being a stressed-out firefighter who's constantly chasing deployment bleezes to a master system architect who has total engineered control over their environment. Let's get into it. So, I want you to picture this scenario. A fire alarm starts blaring in your office. The lights are flashing, the siren is absolutely screaming, and everyone is just standing around, just staring at each other, waiting for someone else to step up and buy a fire extinguisher. Sound familiar? Well, that is literally what happens when you have a blinking red dashboard, but zero feedback loops in place. Your system is screaming for help, but who actually fixes it? And this hits on the core difference between passive observability and continuous improvement. Passive observability, that's just knowing your Solana deployment is broken. Honestly, that just gives you incredibly expensive anxiety. But continuous improvement, that is about absolute control. It means knowing exactly who steps in, what specific actions they're going to take, and exactly how they fix it, ideally before your users even realize there was a glitch in the matrix. Here is the architectural blueprint we'll be drafting today to turn all that deployment chaos into engineered control. We're going to cover moving from monitoring to action, the anatomy of a feedback loop, inventorying and classifying your signals, nailing down owners, cadence and triggers, drafting improvement cycles, and finally, validating your plan. All right, let's kick things off with section 1, from monitoring to action. So, as we talked about earlier, our previous alignment work gave us observability. But here's the thing, observability without action is honestly just a recipe for a team-wide panic attack. We really have to do more than just sit back and watch telemetry graphs bounce up and down. We have to operationalize those graphs. The absolute key takeaway here is this. Alignment creates observability, but feedback loops create action. Those monitoring metrics aren't just passive dashboards for you to stare at while sipping your morning coffee. No, they are direct, immediate triggers for regular, testable improvements in your deployment framework. They are basically the starting gun for your engineering team. Moving right along to section 2, the anatomy of a feedback loop. Okay, let's establish exactly what we're talking about. A feedback loop is a structured process that converts monitoring signals into concrete prioritized changes within a deployment framework. It's essentially all about closing the circle between what we observe happening on the blockchain and what we actually do about it in our code and infrastructure. This right here is the core mechanism that finally puts a stop to that endless cycle of ad hoc firefighting. And here is the exact sequence of events that you need to define in your plan. Step 1, a signal appears. Step 2, you apply allowed decisions at a specific, predefined cadence. Step 3, you either roll back or promote the fix. It is that straightforward. Because when a Solana node issue arises, your team shouldn't be blindly guessing in a Slack channel, right? They should be seamlessly executing these exact, predefined steps like clockwork. Next up, section 3, inventory and classify signals. Now, we actually need to go out and gather the data points from our system. A good rule of thumb is to aim for at least 3 distinct signal sources across different system layers to really form a solid foundation for your plan. First, you might look at your CI pipeline or smoke test logs. Those act as your signal for correctness. Second, you definitely want to look at RPC latency from your observability tools to measure performance. And third, you're going to need failed transaction logs to measure direct user impact. But here's why this matters. Classifying a signal directly dictates your immediate mitigation action. Because, let's be real, signals are absolutely not created equal. A correctness issue, like a failed assertion in a smoke test, means you immediately block a deployment. Boom, done. But a performance issue, like elevated RPC latency, well, that might just mean you need to scale up a node. You wouldn't treat a minor UI bug the exact same way you treat a complete catastrophic node outage, right? The priority always dictates the response. All right, that brings us to section 4, owners, cadences, and triggers. Now we are drafting what is absolutely the most critical part of our entire blueprint. We're taking all this theory and making responsibility and timing completely explicit. And let me give you a massive pro tip here. Assigning a critical bug to the team is the absolute fastest, most reliable way to guarantee that nobody fixes it. Literally nobody. Everyone just naturally assumes the other person is handling it. Good ownership names a specific role, like release engineer or infrastructure engineer. Just please don't use vague terms and definitely don't just dump an alert into a group chat hoping a hero magically emerges to save the day. Instead, compacting our entire strategy into a single executable matrix is gonna be your best friend. In this kind of setup, we have the signal, RPC latency, the measurement cadence, we check it every 15 minutes, the explicit owner, the infrastructure engineer, and the immediate triggered action, scale the nodes. There's no panic, there's no confusion, it's just pure engineered execution. So, for example, let's say your sustained RPC P95 latency hits a threshold of greater than 300 milliseconds. When that happens, there is zero debate. It acts as an unignorable trigger that initiates our feedback loop immediately. The designated owner sees that number, references the protocol, and takes the predefined action. Simple as that. Okay, let's move on to Section 5, Drafting Improvement Cycles. This is where we transition from applying those quick temporary bandages to engineering long-term structural fixes that stop the fire from ever starting in the first place. See, by pairing immediate mitigations with a retrospective improvement ticket, we prevent emergency firefighting from becoming the permanent status quo for your engineering team. To do this, you need to establish a weekly or bi-weekly cadence to review incidents, you need to assign owners to the actual improvement cycle itself, and you absolutely must define specific, measurable acceptance criteria to make sure the problem is truly solved. The crucial point here is that your acceptance criteria cannot be something vague like, oh, just make the server faster. It has to be hyper-specific and measurable, exactly like this. Reduce average RPC P95 latency from 350 milliseconds to 200 milliseconds in staging after scaling changes across 2 test runs. That leaves absolutely zero ambiguity about whether your structural fix actually worked. At the end of the day, you either hit the numbers or you didn't. Which brings us to our final section, Section 6. Validating your plan. Before we commit this beautiful blueprint to a live environment, we really need to stress test it to make sure it holds up in a real crisis. In fact, I'd encourage you to role-play a scenario with your team right now. Pick a situation. Pretend a pre-deploy smoke test just totally fails. Now look at your plan. Does it clearly dictate exactly who stops the deployment? Does it state exactly what the temporary mitigation is? And, crucially, you have to confirm that the metric you're relying on actually exists in your monitoring tools. Because let me tell you, a theoretical metric is not going to save you during a real outage. As we wrap up this framework, I want you to keep these 3 golden rules permanently stamped in your mind. Make your signals actionable, make ownership explicitly clear, and make your improvements measurable. If you stick to those 3 pillars, your feedback loop is going to remain resilient, highly effective, and perfectly scoped for your day-to-day operations. Which leaves us with this final, incredibly important question. If an alert fires on your system, right now, at this exact moment, does your team know exactly who owns the fix and exactly how to measure success? Because if the answer is no, well, you know exactly what you need to start building today. Thank you so much for joining me for this explainer. To dive deeper into Web3 deployments, Solana, and to explore a ton of other amazing educational resources, be sure to check out forge.college. I'll catch you in the next one.